Hey guys, so we're on to lesson number 4, which is all about subtracting polynomials. Now, subtracting polynomials is really similar to adding polynomials in a lot of ways. There's only one real major difference. So when we are subtracting polynomials, here's the recommended way to look at it. The first thing you want to do is remove the first set of parentheses. So remove the first set of parentheses because, again, remember, that is like multiplying by a positive 1. And when we multiply by positive 1, that doesn't change anything. So we remove the first set of parentheses. All right? Then, after that, we're going to distribute or multiply every term in the second set of parentheses by -1. So we're going to multiply every term in the second set of parentheses by -1. And the reason for that is we're going to have, again, we always have a 1 in front of that. Well, because of the subtraction symbol between the polynomials, this is like multiplying by -1. Now, what you probably remember from previous conversations and stuff that we've gone over is that when you multiply something by -1, it only makes one significant difference. It doesn't change any of the numbers, but it does change whether it's positive or negative. Anything that's negative will become a positive, and anything that was positive will now become a negative when you multiply by -1. After you've done that, then we'll go into our normal routine of once we've got those terms, we'll separate them out and we'll combine our like terms. And then we're going to make sure that it ends up in standard form. All right, so I kind of wrote out, as I was talking about that, kind of the start of example A. So we've got these polynomials of 4n squared plus 5 being subtracted by -2n squared plus 2n minus 4. So again, really what we're doing is we're just going to remove the first set of parentheses because we're only multiplying that by a positive 1, which doesn't change anything. So this becomes 4n squared plus 5 without the parentheses. Nothing really changed. Now on the second one, we're multiplying by -1. So it's not going to change really any of the numbers. It's just going to change whether it's positive or negative. -1 times -2n squared is positive 2n squared. And -1 times positive 2n is negative 2n. And -1 times -4 is positive 4. So all it really does is switch the symbols, whether it's positive or negative, of every term in the second parenthesis. So once we're to this stage, we're exactly like we were with adding polynomials. We've got to separate out our terms, figure out what our like terms are, and combine them. So anywhere I see a plus or a minus sign, I'm going to create those little slashes, and I'm going to separate out my terms. Then I start with my first term, so I'm going to start with 4n squared, and I'm going to look for any other terms that have n to the second power. Well, I see one other, and it's this positive 2n squared. So I'm going to combine the coefficients. So 4 plus 2 is 6, and they are n squared kind of terms. Then I'm going to move on and do my next term, which is a positive 5. Now that's just a number, so I'm looking for other terms that are just numbers. And the only other one I see is positive 4. So positive 5 plus 4 is positive 9. And then my only term left is this -2n, so I'm going to bring that down. Now, last step, again, is to always make sure it ends up in standard form. So is it moving from the biggest exponent to the smallest? Well, if you remember back in previous lessons here and at the beginning of vocab, I mentioned that numbers by themselves have a degree of 0, and so they are always the last term. Well, when I look at the polynomial I have currently of 6n squared plus 9 minus 2n, the number is in the middle of it. So I need to move that all the way to the end. So again, I'm going to separate these out, and I'm going to get them in order from biggest exponent to smallest. Well, my biggest exponent is my 6n squared, so that's going to stay the same. My next biggest exponent would be the -2n. And then the positive 9 would go to the end. So we didn't combine anything because we had already done that, but we did rearrange to get it into standard form. All right, well, let's take a look at example B together. So example B, again, remember, when we are subtracting polynomials, and we know we're subtracting because of this subtraction symbol, we're just going to remove the first set of parentheses. So I'm going to leave every term inside there exactly as it is, just remove the parentheses. So I'm going to have 4x squared minus 3x plus 5. Then I'm going to multiply every term in the second set of parentheses by -1 because I really have a -1 or a -1 right there. So I'm going to multiply -1 times 3x squared, which is -3x squared. -1 times -x, which is positive x. And -1 times -8, which is positive 8. So again, remember, it's not really going to change any of the numbers or variables or anything like that. It's just going to change the sign in front of it. If it was positive, it becomes negative. And if it was negative, it becomes positive. Well, at this spot, now we're into it where we should be dividing up our terms and combining any like terms that we see. So everywhere I see a plus or a minus, I'm going to put my slash. And then I am going to start with the first term and look for any terms that are like it. So 4x squared. So I'm looking for terms with an x to the second power. Nope, nope, yep, x to the second power. And then the other two are not. So I've got 4x squared and then a -3x squared. Well, again, combine the coefficients. 4 minus 3 is 1. So really I have 1x squared, or I could just write that as x squared. Whether I write it as x squared or 1x squared, it means the exact same thing. Then I move on to my next term. So I've got -3x, right? Do I have any other terms with x with no exponent listed? I have one other that I see here, so positive x. So -3x plus x, remembering this is a positive 1x. So -3 plus 1 is -2, and they are x terms, so -2x. And then my next one, I've got positive 5. That's just a number, and I have one other just number of positive 8. Well, positive 5 plus 8 is positive 13. So at this point, I've got x squared minus 2x plus 13. I need to make sure that's in standard form. So biggest exponent to smallest, numbers should always be at the very end, which they are. So that is already in standard form, and I am good to go. All right, well, I'd encourage you to try example C on your own, then check your answer with mine. So example C says p squared plus p plus 3, all minus -4p squared minus p plus 3. Well, first thing, remove the first set of parentheses. So this is p squared plus p plus 3. Second part, multiply the entire second parentheses, each term individually, by -1, which doesn't change any of the numbers, but only changes if it's positive to negative or negative to positive. So this becomes -1 times -4p squared is positive 4p squared. -1 times -p is positive p. And -1 times positive 3 is -3. Now at this point, we should be dividing up our terms. So anywhere we see a plus sign or a minus sign, put our slash, and it goes in front of it, not after it. And then start with our first term and start combining any like terms. So first term is p squared, so I'm looking for any with p's to the second power. I see I have 1 right here. So I've got p squared plus 4p squared, remembering that this is really just 1p squared. So 1 plus 4 is 5, and they are p squared type of terms. Then I've got positive p here, and looking for any other p's with no exponent listed. I've got another positive p. Well, that's like 1p and 1p. So 1 plus 1 is 2, so I've got positive 2, and they are p terms. And then last ones I've got is positive 3 and -3. Well, positive 3 and -3 make 0, so I have nothing left of those terms. So my final, or not final, but my polynomial at this stage is 5p squared plus 2p. I need to check, is it in standard form? So biggest exponent to smallest. It is. So that is my final answer. All right, well, I'd encourage you to try example D on your own, then check your answer with mine. So D says negative k plus 5 minus the polynomial of 3k squared minus 6. So again, bring down the first parentheses exactly as it is without the parentheses. So negative k plus 5. Then multiply the second parentheses by the negative 1 out in front. So that makes that negative 3k squared, and then positive 6, because negative 1 times negative 6 is positive 6. Now I need to divide up my terms, so anywhere I see a plus or a minus, I divide those terms up. Then I need to, from there, start combining like terms. So my first term is negative k. Do I have any other terms with k to no exponent? No, I don't, so I'm going to bring that down, so that's negative k. Then I go to my next term, so that's a positive 5, so I'm looking for other just numbers. I do have one of those. I've got a positive 6 here, so positive 5 and positive 6 make positive 11. And then the only term I have left is the negative 3k squared, so I'm going to bring that down. Now, last step is I need to make sure that it is in standard form. So when I look at this, I see that my biggest exponent is not at the beginning and my number is not at the end. So I'm going to divide them up so I can see each term individually. My biggest exponent is negative 3k squared, so that's going to come first. My next term would be the negative k, and then my last term would be the number of positive 11. So negative 3k squared minus k plus 11 is my simplified polynomial in standard form. All right, well, if you have any additional questions, please feel free to reach out. But otherwise, you should have what you need to continue on in the lessons.